Mary, my head's on the block. This investigation isn't an open-ended research problem. We've got a deadline.
Deadline? What a dreadful word that is. Since there is a time limit, why is it your first priority to check out a well-tried chemical process? We have this whole list of things that could have caused the shutdown.
Chemical process is not well-tried as far as your vaccine is concerned. You only discovered it a few years ago.
Congratulations, Mary. It was a great breakthrough.
Oh, thank you, Danny. They're lovely, but you shouldn't.
You deserve the best. One day, thanks to you, we'll conquer schistosomiasis.
I'm afraid we're a long way from that, Elmira. We've got so far as an antigenic protein.
All. She says that's all.
No, I mean it, Danny. It's only a beginning. And we shan't get much further unless we have help.
More money.
More money. Things began well. A large pharmaceutical company, VPI, took an interest in our work. They sent 2 of their executives to find out more about it. That was our first meeting with Pierre Prunier and Mr. Kluber. It was an important lesson for Danny and Elmira. Anyone who wants to succeed in scientific research must learn how to obtain financial backing.
Mr. Kluber is our financial advisor, not a biologist. Perhaps you could explain to him what you are doing, Professor Edwards.
Of course. Are you familiar with schistosomiasis, Mr. Kluber, or bilharzia, as it's also known?
I know only that it is a disease caught from wading in rivers and streams.
This illustrates the life cycle of the worms which cause schistosomiasis. Let's start with the Cercariae. They are like tiny tadpoles with forked tails. They penetrate the human skin and make their way to the liver. There, they develop into these schistosomes, which settle into the veins surrounding the intestines or the bladder. The male schistosome encloses the female, and they produce eggs, about 1 egg every 6 minutes for a number of years.
Years?
If the patient lives that long.
The eggs cause damage to the ureter, the liver, and the bladder, and other parts of the body, particularly those which get stuck in the tissues. Eventually, some of the eggs are excreted into the water where they hatch. At this stage, they're called mericidia. Now they penetrate into the water snails. These are infected snails. In the snails, the mericidia develop into Cercariae, and they break out into the water again.
So, more people get reinfected, and the cycle goes on.
Don't we produce drugs to treat bilharzia?
Yes, but drugs are expensive. Eradication's too slow. People go back into the water, get reinfected before the disease has been brought under control.
It's generally agreed that immunization is the best answer. But so far, no one has produced a suitable antigen. Or vaccine, if you prefer.
But you are making progress.
Oh, yes. Elmira, perhaps you'd like to show Mr. Kluber what we've done so far.
A traditional method of immunization, injecting dead organisms, doesn't work with schistosomes. Dead schistosomes are not very effective. Therefore, we had to find a different approach. If you look through here, you can see a Cercaria magnified. Professor Edwards took a number of protein molecules from the surface of the Cercariae and tested them on mice. One of the proteins proved to be protective. That is, it stimulates the mice to produce antibodies that kill the disease. We assume that it is also immunogenic in humans.
So now you can inject people with this protein, and that will prevent them getting bilharzia.
In theory, yes. But in fact, it would be impossible to obtain enough protein from Cercariae to inject millions of people all over the world.
Ah, yes.
Nor can we manufacture an entire protein. The chain is far too long and the structure much too complex.
That's why we must go further. We must isolate a shorter sequence from the protein chain. We must find the active part of it, the part which is immunogenic. That may be only a 10th or even a 100th part of the whole. It's that part which needs to be synthesized on a commercial scale by a firm such as yours, Mr. Kluber.
I take it you're analyzing the protein.
Yes, Danny's working on it now. This way.
You see, all proteins are built up of chains of amino acids. There are around 20 different kinds. This analysis shows us which amino acids the protein contains and in what concentration. We also determine the sequence in which they appear so that we can build up an entire picture of the molecule.
The sequence of the amino acids and their spatial arrangement determines the properties of the protein. May we see the result of your tests on the mice?
Of course. Come to my office.
These results seem to be conclusive, Professor Edwards. I congratulate you.
It's a hard task. And our financial resources are very limited. We'll also need help in synthesizing the polypeptides for our experiments.
So you'd like our company to help you do that?
It would give you a commercial interest in the product.
I should point out that selling drugs to third world countries is not very attractive commercially.
But it's worthwhile in other ways, Mr. Kluber.
I am an accountant, Professor Edwards. Besides, you haven't found your polypeptide yet. There's no certainty that you will.
True.
But the company may be prepared to assist you, even if the profit margin is low.
We cannot make an open-ended commitment at this stage.
No, but we can make a modest contribution.
A modest contribution?
To keep the professor going, out of our current research and development expenditure.
Ah, yes.
Call it an option on future rights. I suggest we talk about this matter again when you find a polypeptide which is immunogenic.
If you find it.
Now, this sequence looks very promising. From number 90 to 130. Morning, Danny.
Morning. I'm sorry I'm late, Mary. I overslept. I didn't get to bed until the early hours of this morning.
Another party?
No, not exactly. I was reading a paper called The Antigenic Properties of Short-Sequence Polypeptides, okay? A bit dull, but instructive.
Glad you read my work, Danny. I've selected some candidate polypeptides.
But how do you decide which to choose?
Experience, of course. And blind hope. Your guess could be as good as mine. Which one would you choose?
Oh, so this is like picking a winner in a horse race.
The pharmaceutical firm helped us by synthesizing small quantities of the polypeptides that we had chosen for further experiment.
They're all here. Very efficient.
Oh. Why do I have to waste my time lecturing to idiots?
Because if you didn't, you wouldn't have postgrad idiots like Elmira, us, to work for you.
You have a point there, Danny. What's this?
It's just arrived from VPI.
Excellent.
All we have to do now is find the winner, if it's there.
We'll start testing right away.
4043.
A32, dose 50 micrograms. It was a very long process. In order to boost the immunogenic effect of the polypeptides, we attach them to an adjuvant and a large molecule, which acts as a carrier and is non-toxic. It would be safe to inject into humans, if we ever got that far. In several cases, the mice developed antibodies, but when we challenged them with Cercariae, they developed schistosomes. They had responded to the polypeptides, but were not protected against the actual disease. We're not very good at picking winners, are we?
Perhaps one of our sequences is right, but the structure is wrong, that's all.
I'm afraid that's where everybody fails when they try to synthesize antigens. Unless the polypeptide folds in exactly the same pattern as it does in the original protein, it may not protect against the disease.
What can we do about it?
I'm afraid nobody has discovered a way to create the right configuration in a laboratory. Looks as if we've failed, like everyone else.
Oh, hello. What brings you here?
Saw the light on. Does Mary know about this?
No, and there's no need to bother her unless it works, huh? Syringe, please. Make a note. 500 micrograms.
500?
That's right. And mark its sequence K40.
Still can't believe it.
Oh, you beautiful little creature. Not one schistosome in your body.
K40, that was my favorite candidate. What made you try a dose as big as 500?
You did. In a paper you wrote, you said, a short polypeptide was less likely to be antigenic than a complete protein.
Of course, that's why I put it up to 250.
I thought maybe even that wasn't enough, and I doubled it.
Clever of you, Danny.
I'm not just a pretty face, you know.
And what's more, the configuration must be right.
For sheer luck.
Shh, there's no need to tell anyone that.
We'll test it again and again. Then when we're quite certain, we'll inform Mr. Prunier. And this is the polypeptide that we've labeled K40. As you can see from the papers I've submitted, we've repeated the experiment with 20 mice, each time with positive results. What we need now are supplies of K40 for toxicity tests, first with primates and then with human volunteers. If these are successful, we can then go on to a full-scale field trial.
Thank you very much, Professor Edwards. I think we're all very impressed with your results so far.
I must point out that trials are expensive, and you can never guarantee success.
But there is a very good chance in this case.
There is another matter I should mention. We had difficulty synthesizing K40. Oh, I can supply enough for clinical tests, of course. But there might be problems in producing it commercially.
You mean it wouldn't be economically viable?
I can't say for sure at this stage.
I do hope, gentlemen, that you will go ahead in view of the potential benefit to mankind.
We're here.
Good afternoon. You wish to examine our process for synthesizing polypeptides, I believe.
Dr. Markowski would like to do so.
What do you hope to find?
Any possible reason for the breakdown in our space production unit?
How could our process be the cause of the breakdown?
Well, if there was an impurity in the base product...
Impurity?
I said if. If there was an impurity, it would have built up in one of the tubes and caused a blockage in the system.
Of course, we realize that it's highly unlikely.
You do understand that when we build up a polypeptide chain, we test the product at every step.
What is more, in this case, the two chains we synthesized were purified and thoroughly tested before they were hermetically sealed for the space flight. Our tests showed that there were no impurities in the base products. We are a pharmaceutical company. We do not tolerate impurities.
I understand that, Dr. Mann.
Gentlemen, no need to argue. Let us show you the process in action, and you can judge for yourselves.
Fine.
You know, Pierre, that day I first spoke with your directors, I never thought they'd go ahead with this project. It was a critical moment.
Yes, if I remember well, half were in favor and half against.
Yeah, that Mr. Kluber was against. So much concerned about the financial risks.
Ah, you mustn't be too harsh on financial advisors. They are very necessary, you know? As a matter of fact, it was Kluber who tipped the balance in your favor.
Kluber?
Yes?
In my favor?
Mm-hmm. He said we should take financial risks on humanitarian grounds.